Hello everyone. The topic that we are today going to discuss is cut sets, Euler graph, and Hamiltonian graph. So the first point is cut set. The set of all the minimum number of edges of G whose removal disconnects a graph G is called cut set of G. Thus, cut set of S satisfies the following. S is a subset of H set E of G. For example, consider this graph. In this graph, when the cut set edges A, C, and H are removed, we get these two separate graphs. So the cut set of the given graph is A, C, and H. ACHD is not a cut set because its proper subset ACH is a cut set. This is the second example. In this graph, the cut set is A, B, E, and F. The next point is Eulerian graph. For that, we will see the first point, Euler path. A path in graph G is called a Euler path if it includes every edge exactly once. Since the path contains every edge exactly once, it is also called as a Euler trial. Next is Euler circuit, and Euler path, that is a circuit, is called a Euler circuit. A graph which has a Eulerian circuit is called as an Eulerian graph. Example. This is an example of an Eulerian circuit. In this case, the given graph has an Euler path, which means if we start from the point C, all the edges are included exactly once. But in other case, it is not an Euler circuit. The given circuit is not an Euler circuit because the starting and the ending points must be same, which is not satisfied in this example. So as it is not an Euler circuit, it is also not an Euler graph. In this example, Euler path is present, even the Euler circuit is present. Therefore, graph is Eulerian. Here is one more example. In this example, Euler path is not present as all the edges are not being included, and as it does not satisfy the basic property of having Euler path, therefore it is not an Eulerian graph. Whereas in this example, Euler path and Euler circuit both are present, therefore it is an Eulerian graph. The next point is Hamiltonian graph. First, we will see Hamiltonian path. Hamiltonian path is a simple path that contains all vertices of G, where the endpoints may be distinct. Hamiltonian circuit, a circuit in a graph G that contains each vertex in G exactly once, except for the starting and the ending vertex that appear twice, is known as the Hamiltonian circuit. So, in Hamiltonian path, all the vertices must be included, and in Hamiltonian circuit all the vertices must be included once exactly except for the starting and the ending vertices. And a graph G is called a Hamiltonian graph if it contains a Hamiltonian circuit. Here is an example. In this graph, if we start from vertex V1, all the vertex V1, V2, V3 and V4 are included. And V from V1, if we start the circuit, it ends upon V1, making it an Hamiltonian circuit. Therefore, it is an Hamiltonian graph. While in this example, Hamiltonian circuit is not present because the starting and the ending points of the circuit are not same. Therefore, it is not an Hamiltonian graph. Next point is planar graph. A graph G is said to be planar when it can be drawn in a way so that its edges do not cross each other. A graph G is said to be non-planar if it cannot be drawn on a plane without crossing its edges. The geometric representation of a graph on any surface such that no edges intersect is called as embedding. Here are some of the examples of planar graphs. This is an example of a planar graph. This graph we can draw in the similar way which is shown here, which makes it an planar graph. Thank you.